Hi guys, this is chapter 1 and I'm going to go through it. The first thing we're going to talk about is scientific notation. We use scientific notation so that we can take a very large number or a very small number and make it more usable. Correct scientific notation is number, decimal, number times 10 to the power of. Okay, so we have 6,300 meters or we have 0.000045 meters. Okay, so if we were to convert these two, how would we do it? Well, we would put the 6.3 with one more zero times 10 to the third. How do you get that? You move the decimal 1, 2, 3 places. Okay, so it went 3 to the left, so it's positive 3. This one, we're moving it 1, 2, 3, 4, 5, and we're moving it to the right, so it's a negative. So it's 4.50, even though 0 is not there, because correct scientific notation always has 2 decimal points. Okay, and this is what we're going to be using anytime we have large numbers or small numbers. Now, on your tests on Blackboard, a lot of times they will basically ask for an answer in scientific notation, and that's when you would do like 6.30 E3 or 4.50 E minus 5. That's how they do it on the tests. They use the E instead of times 10 to the power of. Might be a little confusing, but on the test, if I want it in scientific notation, I will actually remind you that's the correct way to do it. Okay? All right. All right. Now, the next thing we're going to be talking about is vectors and scalars. Okay, a vector is a quantity which has a value, which is magnitude, and a direction. So some examples are displacement. Displacement is distance with direction. Distance is usually measured in meters, kilometers, feet, miles, stuff like that. Velocity is speed with direction. Okay, and those are usually measured in meters per second or kilometers per hour or feet per second. Okay, acceleration is the rate change of velocity or speed, and that is measured in meters per second squared or feet per second squared. Force is a measurement of weight, which is measured in newtons or pounds, and weight is also a force. Okay, and those are measured in newtons or pounds as well. Now, a resultant is the sum of the vectors, and there are 3 ways to find the resultant. Okay, now if you think about it, all vectors have an amount and they have a direction. So we can represent each vector as an arrow, and the arrow has to have an arrowhead. If it doesn't have an arrowhead, it's not a vector. Okay, and there's 3 ways to do this. The head to tail method, that's the one I prefer. The parallelogram method only works for 2 vectors. Okay, if you have 3, you can't use it. All right, some people just like to use it because you're basically making a parallelogram and splitting it. And then the last one is the mathematical way to solve for this. And this is the sum of the horizontal and vertical components, because every vector we give you can be broken down into 2 pieces, a horizontal component and a vertical component. And then all you do is basically use Pythagorean theorem. Okay, the head to tail method. Connect every vector from head to tail, then connect the tail of the first vector to the head of the last, and this is your resultant. So we're going to go through an example here. All right, so we have a man, he walks 4 meters east and then 5 meters at 45 degrees north of east. So step 1, we draw the first vector to scale, and we label the vector and the scale. Now the scale here that I would use would be like 1 meter equals 1 centimeter on my paper. So I would make this arrow 4 centimeters long. All right, with the arrowhead facing east. East is to the right, west is to the left, north is up, south is down. The next vector is drawn from the head of the first vector, and it's drawn 5 centimeters long at 45 degrees north of east. Now, this is where you have to have a protractor, okay? And you would place the protractor across here like this, and then you would read from this side of the protractor going upwards, and it would register at 45 here, okay? Never put the protractor base on an angle. Always keep the protractor's base horizontally okay? And you're either going to have the top so that it goes this way or it goes that way. All right, so in this one, we're going to draw the resultant, and the resultant is drawn from where you start to where you finish, okay? And then you measure the length of this arrow. And if you drew this 4 centimeters long and this 5 centimeters long at 45 degrees, this should be about 8.3 centimeters long. And the angle here, we place our protractor like this across the bottom, and then measuring from here going up, we would measure 25 degrees north of east. And that's how you would do the head to tail method. Okay, method 2 is the parallelogram method. Now this is just an easy way to say, okay, I'm going to draw the two vectors and I'm going to then bisect them. But you have to draw them both this twice. Now it seems like a lot of extra work, but there's some people that just really, really like this method. So I always throw it in here. I like method 1 the best. All right, so step 1, we do the same thing. We draw the 4 meters east. Step 2, now we draw the 5 meters at 45. Then we draw another 4 meter and another 5 meter at 45 degrees, and it gets a parallelogram. And then all you have to do is just bisect it. And when you bisect it, once again, you'd measure the length of this, and you would get 8.3 and 25 degrees north of east. All right, same thing.